this video, we will be demonstrating the unsymmetrical bending and shear center experiment, the STS7, in the next generation structures range from TecQuipment. This allows you to study the vertical and horizontal deflection of different unsymmetrical sections. When choosing a beam for a structure, engineers would usually choose one with a symmetrical cross-section, but in some situations you cannot load the beam in the direction of the principal axis. In certain situations, it is also more convenient or structurally efficient. As a result, bending can occur in both directions and the beam. If the load is not in the shear center, then the beam may twist. This can be very destructive. Being able to predict how a beam will behave in a structure, such as an aircraft, is therefore critical. Continue to watch this video as we look closely at the apparatus and go through the different experiments. Let's take a closer look now. The experiment apparatus mounts on the separately supplied structures platform, the STS1. We call this side the measuring end, and this the clamped end. At the measuring end, there is a large right-angle plate that fixes to the structure's platform. Fitted to this using a strong magnet is the indicator carrier plate, with the purpose of holding these two precision deflection indicators and a small bubble level to help you align the indicators before measurements are taken. Readings can be taken directly from the readout and the precision deflection indicators, or you can plug them into the USB interface hub, connect to a computer running the free-to-download VDAS software, and use that to collect, chart and help you analyze the results, depending on your preferred method of data capture and analysis. Using the VDAS option means that you can also upgrade to VDAS eLab functionality to allow students to engage in your practical session remotely on their own computers for individual data capture and analysis anywhere in the lab, remotely anywhere in the world. On to the clamped end now. This is another end plate fixed to the structure's platform. It holds a chuck that grips the end of any test beam as a cantilever. You can see that the chuck has markers at 22.5 degree intervals so that the axis of the test beams can be accurately rotated. There is another small bubble level to help you level the platform before beginning. When doing the shear center experiment, the shear center plate is attached to the end of the channel section beam, and you apply loads at 5 mm spaced positions along the plate. To apply loads, we have two mass hangers and a bundle of 25 individual 20-gram metal discs. 3 aluminium test beams are included in this experiment, each with the same length and weight but different cross sections. An L-shaped, U-shaped, also referred to as the channel-shaped beam, plus a rectangular shaped beam. A vernier caliper is included for accurate measurement of the beam cross sections. There are two different experiments a student can perform with this experiment kit. The first experiment looks at both symmetrical and unsymmetrical bending. The chuck clamps the beam while allowing rotation on its axes and allows loads to be applied at various angles using the weights here. The load applied at the free end produces resulting deflections, measured by the precision deflection indicators. You can plot the results on a Morse circle, which then allows you to find the principal second moment of area and position of the principal axes. These may be compared to those for the arbitrary section axes and the values calculated by textbook beam equations. You can watch a separate video that shows how to carry out this experiment and see some sample results. On to the second experiment looks at the shear center of a U-section beam, also known as a channel beam. A plate is clamped to the free end and allows various offset loads to twist the beam. You apply loads at various offsets and use the indicators to determine when the twist is 0. This is the shear center position. We hope you found this video useful. If you would like to find out more, click on the links below. This is one of the 21 different experiments within the next generation structures range from TecQuipment. You might also like to check out the Euler buckling of struts and the unsymmetrical cantilever experiments to complement the learning outcomes we've talked about today. Thank you for watching.